Okay, ladies, so in this video, we're going to continue with function transformations. I'm going to put all of it together with just a couple examples, and then we're going to talk about absolute value equations. So here, let's just take a look at y equals 2x squared plus 2. Right, so let's think about what transformations just from the equation that we can see. So I can see a 2 times x squared. So this is a vertical stretch, right? That's like a vertical stretch by a factor of 2. And then I have the plus 2, which is a vertical translation up 2 units. So let's graph this. So I'm not going to graph the parent function this time. I'm just going to graph our translations, right? So if we think about our parent function's vertex was on the origin, so let's take that vertical translation first. It will be up 2, okay? And then we have this stretch by a factor of 2. So with quadratics, it's really easy to sort of use this as our way to graph. If I go over 1, then I'm going to go up 2, right? If I just ignore this for a second, 1 squared times 2 is 2. So 1 squared times 2 is 2. Same thing over here, up over 1, up 2. And then if I went over 2, it would go up 8, remember, and that's way up there. So this is going to be a super skinny parabola that's been shifted up 2 units. Okay? Let's do one more. Hopefully this stuff isn't like brand new to all you guys and it's pretty straightforward. So let's try this one. Negative, I'm going to add a few more, x plus 4 squared minus 2. So here we have a bunch of transformations. Again, let's take a look at each one. The negative in front, that is a reflection, reflection in the x-axis, right? I know that because it's outside this set of parentheses, right? If the negative was inside, it would be a reflection over the y-axis, but the negative is outside, so it's a reflection over the x-axis. We have plus 4 inside, right? Plus 4 inside our parentheses, so that's a horizontal translation 4 units left. And then we have the minus 2 is a vertical translation 2 units down. Right? So it's good to know all of these, the way these transformations work algebraically by just looking at the equation. And then we can graph. So let's see. So we know it's going to be a reflection. So actually, since it's a parabola, that means it's going to be upside down. So let's take a look. We got to go 4 left. Okay, let me do it. 4 left, 1, 2, 3, 4, and 2 down. 1, 2. And then there's no stretch or anything. So with quadratics, again, if I'm thinking about just x squared, right? Think about x squared when you graph these and plug in those numbers, right? So if I did x squared, I plugged in a 1, and that would give me a 1, or a negative 1 would give me a 1, right? 1, 1. If I went over 2, 2 squared would be 4, and we'll talk more about this actually in person in class because I'm hopefully getting it, but maybe not. So there we go. So again, I went 1, 1, 1, 1, and then I went over 2, down 4, over 2, down 4, and that's how we got that graph. Okay? Alright, let's take a quick look at some general absolute value stuff. Hopefully this video won't be as long as the previous. It shouldn't be. Alright, absolute value functions. Now I know we did some solving absolute value equations. We're going to focus on absolute value functions. We're going to look at a general form of this actually. Okay, we're going to look at the general form, and actually we're starting this general form thing with absolute value, but this general form will actually look similar in all kinds of functions, right? So it's going to be an A, that's going to represent our vertical stretch and compression, times the absolute value of x minus h, right, which represents our horizontal translations, and then plus k, which represents our vertical translations. And so just to clarify each of these transformations in the general form, let's take a look at how they transform, right? So if a is greater than 1, this is our vertical stretch. Okay, that's going to make our graph skinnier. If a is between 0 and 1, right, if it's a fraction, that's going to be our vertical compression. And then we have our minus h. So if h is greater than 0, this is going to be a translation to the right. This is a horizontal. I should have put that in front. Right? That's a horizontal translation to the right. Now, if h is positive, h greater than 0, this remains x minus h, right? If h equals 2, this will be x minus 2. So the minus 2 is still there, so that's a translation to the right. Now, if h is negative, right? If h is negative, when I plug in negative, for example, negative 2, this actually becomes x plus 2. So that's a translation to the left. So that might help actually explain, too, why the minus and the plus are opposite translations, right? They're not intuitive. Well, it's because the h itself is what determines whether or not it's a right or left. So when h is positive, this is x minus h. When h is negative, it's x plus. Hopefully you understood that, right? So if k is greater than 0, these are vertical translation up. And if k is less than 0 or negative, that's a vertical translation down. Okay? Now let's take a look at a few of our general, typical... Where'd my black marker go? I lost the marker. Well, I guess I'll have to do it. Oh, there we go. Okay, sorry. Lost my marker. Alright, here we go. Our basic parent function, right? Y equals the absolute value of x. Ay, that was bad. Sorry. So, right, if I plug in 0, I get 0. If I plug in 1, I get 1. If I plug in negative 1, I get 1. If I plug in 2, I get 2. If I plug in negative 2, I get 2, right? So, this is our parent function of the absolute value of x. Notice the slope of this side is 1. I'm going to talk about that. It's really helpful to know what the slope of each side of this is. So this is 1. The slope of this side is negative 1. Okay, that's going to come in handy. Let's take a look at y equals negative absolute value of x. So this is a reflection over the x-axis because it's outside, right? It's outside of the absolute value. So that will constitute the y equals negative f of x, right? So this is just going to be upside down, right? This is just going to flip it right over that x-axis with the same exact slopes of the side, right? The slope of this side is negative 1. The slope of this side is positive 1. Okay? Let's look at a couple others here. So y equals the absolute value of x minus 3. Well, that's just, barely have enough room here, but this will work. That's a translation to the right 3 units. 1, 2, 3. Everything else is the same. Okay, everything else is the same. How about we go to the left, x, absolute value of x plus 3. That's just a translation to the left 3 units. Right? It's plus 3, so that means we go to the left. Everything else is the same. Everything else is the same. Okay. Few more here. Few more. Okay, how about y equals the absolute value of x plus 2? Well, this is a vertical translation, right? It's a vertical translation. So I'm just going to take the original, I'm going to go up 2 units, and everything else is the same, right? The shape of the graph is exactly the same. I haven't changed the shape of it anyway at all. How about y equals the absolute value of x minus 2? I'm sure you're getting the idea here. Maybe even getting a little bored. We're almost done. So here I'm just going to go minus 2. Again, everything else is the same. It's the same shape. Slope's 1. Here the slope of this side, -1. Okay, nothing changes except the location of its vertex. I never mentioned that, but that is called a vertex, just like in the parabolas. Okay, about y equals 2 times the absolute value of x. So this is a stretch. This is a vertical stretch. What that means, it means my slopes, right? The slopes of the sides of my V graph are going to be 2. That's all that is. The 0, 0 stays the same, but the slope is 2. So this is 1, 2, right? Rise over run. So 2, up 2, 1. So we get a skinnier graph. And the slope here, right? M equals 2. M equals -2. Same as what you see in front. Okay, y equals 1/2 x. I bet you can guess what the slopes of these sides are going to be. Right, the slopes on the sides of this absolute value graph are going to be 1/2. Right, what's that? Rise over run, 1 over 2 up 1, over 2 up 1. So we see a much wider V-shaped graph. That is your compression, right? That's your vertical compression. All right, we're going to do one more. Put it all together here. Y equals 3 times the absolute value of x minus 4 plus 2. And let's see, what do we have here? Let's talk about our transformations. So we have our stretch, right? Our stretch by a factor of 3. Minus 4, that's a horizontal translation to the right, 4 units. And the plus 2 is a vertical, can we see it all? Let me move this down. Vertical translation up 2 units. Okay, so let's go ahead and throw this graph on there. So let's see. Let's start with our translations, right? Let's start with that. So we're going to move the vertex, the little point on the V. We're going to move it to the right 4 units, 1, 2, 3, 4, and up 2 units. Okay? And then the slope of our sides are going to be 3 and -3, right? We're talking about absolute values, so 3 and -3. So we're going to go up over 1, up 3, and then to the left 1, up 3. And so we have a skinnier graph than even 2 times the absolute value of x. And there is our graph. Okay, I know I said that was the last one, but I have 2 more, and we're just going to talk about writing an absolute value equation from a graph. Okay, last 2 of the day, I promise. So we're going to write the equation of each absolute value graph. Okay, so the first one Now bear with me, hopefully I don't draw this as terribly as I did last night in my notes. So let's see here. I'm going to do here, up there, and then 1, 2, 3 up here. It would have been easier if I just had graphs ready, but okay, so what are we going to do? We got to look for our transformations, okay? So first of all, let's look at our translations. The vertex went left 2 units and down 2 units. Alright, so let's write these down. And then let's look at the slopes of the side. The slopes is going to help tell us what our, we can tell this is a compression, right? Because that V has been flattened out. So let's take a look. If I go 1, 2, 3, 1, that's what? Rise over 1 of 1/3. Same thing over here, right? So if you just look at the slopes of the sides, you can get that compression. So there's a compression by factor of 1/3. And so we can just write the equation from that, right? The compression is 1/3. Then we have the absolute value of x. Now it was moved to the left, so that means this is +2. And then it was moved down 2 units, so this is -2. Excuse me. Alright, last one. Last one, I promise. Let me just draw the graph. And then we'll go from there. So let's see. There we go. Okay, so again, let's start with our transformations, or translations, I should say. So the point, the vertex, translated to the right 3 units. Okay, up 1, 2, 3, 4, right? Up 4 units. It's upside down, right? Which means it was reflected over the x-axis. Reflected in x-axis. Again, I know that because it's upside down, okay? And then let's look at our stretch. We can tell it's a little skinnier. This is a 1, a 2, a 1, and 2, right? So that means there was a stretch by factor of 2. Okay, so what is our equation? Y equals 2 is our stretch, times out the value of x. It's to the right 3 units, so this has to be -3. And then up 4 units, and we are done. Alright, ladies, so if you have any questions, be sure to let me know. That is absolute value equations and function transformations. Have a great day.